brings into goal perspective, there are several things which it does, but to sum it up, the highlight of it is three things. Scalability, to be able to build a system which starts very small and could really grow to thousands of clusters, and capability to address so many customers, so many products, all that can be brought into the scalability part. But while doing that, if it is very, very expensive, lots of companies may not want to do it, and especially small companies or mid-sized companies could not enter to that. And even for enterprises, it is economical is an important aspect. So that's why economical comes into play, and that's why Hadoop plays an important role, how it is designed to be economical, not that it can be done, but it can be designed to economical. A lot of other systems can do scalability, they can handle a lot of volume, but the cost and the effort which they will have to make that happen will be very high. If you ask to tomorrow your car to suddenly be now start flying, it's not designed for flying. So you can make it flying, but there is so many things which will be put and cost will be very high versus trying to take something which is designed for flying, it will be much, much economical. So that's the promise which Hadoop brings in. It is designed to be economical for similar things in other world compare. And at the same time, it needs to be reliable, available for us to do whenever system consistently over a period of time, 24/7. All that is important part of reliability which Hadoop brings in. Important point which I want people to remember about Hadoop, in short, scalable, reliable, and economical. Now I want to take Hadoop into a very real life. And in my mind, as I said, Hadoop is not necessarily something which started yesterday. Actually, in non-technology world of this open source technology, it's been happening around us, around the world for thousands of years, actually. Not really looked at it in such a way, and I'm surprised the technology has caught up so late in this. So here is what I want to do. Hadoop in real life, day-to-day life. Good example, and try to correlate this with Hadoop. So let's start with it. So in our story or example, there is a teacher. She has a class of students. Every week she teaches a particular chapter or topic to the students, and then she gives them an exam. They write the answer papers. All those answer papers takes it home. To spend a couple of hours spending her personal time doing this. What happens, the classroom definitely increases. There are lots of more people signing up to the program. The several classes have been merged. So from 10 students, suddenly she has got 50 students. She keeps on doing, she has to test, answer papers, and she has to solve those or score those during the weekend, and it takes now for her 6-7 hours. Obviously, she is not happy. And she's also worried about, like tomorrow, there is thoughts about multiple people joining her class online, and they will be able to take the questions and give it back to her. And that is really her worry, whether what will happen if this 1,000 students are joining and I have to check thousands of questions and papers. Her whole weekend will be gone, even that may not be sufficient. So she's definitely seeing a problem scenario with the scale of increase in number of students she has to handle. How to handle this scenario, and she comes up with a very interesting solution. I think many people may have seen this solution in their real life. Their teachers may have done it, or their kids' teachers may have done it. This has been done many times in life. So what the teacher does, next exam, students answer that and they have the answer paper ready. Once that is done, what she says, let's wait. I'm not going to collect the question papers this time. Instead, you all take a red pen. I'm putting all the answers on the board, and you check yourself and score yourself using the red pen. Students, and this whole exercise completes in 15 minutes. She doesn't even have to spend a single minute in her weekend. Things are done. What has happened over here, like she's no more worried about whether it is 10 students, 50 students, or 100 students. She has a solution which is scalable for thousands of students, or even more. Change of approach and her mindset, her solution which brought in, and this is what I would like to say is Hadoop, and it really brings all the whole core principles of Hadoop. So this is a very good example. If you see, I'm sure many people have seen this already in their life happening. We never thought about this as Hadoop or a big data problem. We just thought a problem, she solved a solution through an interesting solution. These are the core principles which Hadoop has brought into our life or this technology space. So let's try to correlate now this. What did happen in this scenario that the teacher was able to do very quickly? So let's take one thing at a time. So these are core principles which we were talking in a more futuristic view. What happened, teacher was going at home, she was checking the first answer paper, then the second answer, third answer paper, and so on and so forth. In the new solution, all of the exam papers were checked and scored at the very same time. They were done in parallel versus serially done by the teacher. So that execution, that brought a speed that everything could have been completed in 15 minutes versus it's taking hours and hours for her. So that's one feature which Hadoop has, parallel execution. Data locality. What happened in data locality? What does it mean? In the first scenario, the teacher was collecting all these answer papers. This effort of collecting all the answer papers to her did not produce any value, not a single paper. If she spent 10 minutes collecting the answer papers, during that 10 minutes, not a single answer papers was checked or scored. So this happens in Hadoop world, these things are not brought in at decentralized location. So let's also try to connect what is present in Hadoop world. Hadoop happens, there is a master node, a master cluster in the whole, this is the whole cluster, the classroom. Consider the classroom as a cluster. And in the cluster, there is a master. And in this case, the teacher is playing the role of the master. There are several, if you would say, in the cluster. And each students are the slave nodes. A Hadoop cluster is defined. Some master nodes, one master node, and several slave nodes. In Hadoop world is not brought in from the slave nodes to the master node. It's not being transferred. It is processed where it is. The answer paper is checked right there and there with the student. The give and take is not happening. That time is not wasted. In Hadoop world, if you move that data, the I/O, the bandwidth which is cost, that is saved. There is no wastage of this time as well as cost. It's happening right in there. In our example also, it's happening right in there and there in the second scenario where the students is themselves checking the answer paper. That's what is called data locality. No Hadoop interview happens without this question being asked. What does data locality mean? And it simply means ability to process the data where the data resides instead of transferring data to one other place. So this is the beauty of Hadoop. And in our example, it's coming out very clearly. Tolerance is a third feature. What scenario in our real day-to-day life, classroom life, where teacher is absent, some substitute coming or in place, and all that hassle may have been taken. But in most chances, the answer paper will not be checked, and none of the students will get their scoring done. If in our second scenario, if one student was sick, then the teacher might probably assign that paper to be checked by some other student. Everything goes as fine, or at least majority of the papers still get checked. The only impact it is a very isolated, specific node, but rest of the things keep moving fine. In fact, Hadoop is designed to such a way that nothing should be in problem. Everything should keep on moving fine, and that's called as fault tolerance. The system is designed to address fault. It's assumed hardware will fail, data will be lost. These things will happen. It's part of their design. And when we talk more detail about Hadoop and the whole cluster architecture, this will come into picture. But in this example, it's very, very evident how fault tolerance is done. And this I don't need to talk about much, the scalability. Remember, we talked about the teacher now be able to handle, even if she has 1,000 students, the amount of time she will need to get those answers in 15 minutes. She's no more stressed. She doesn't have worry about how will we be able to check thousands of paper versus at the same time, it doesn't even increase the amount of time needed because it's thousand or even lakhs of papers to be checked. So that brings scalability into our equation. So in the first slide, we talked about Hadoop having three promises. One was scalability, was economical, and third was reliability. As we talked about, reliability is caused by fault tolerance. Because the systems can go down and some other person will be able to take that work or some other node will be able to take that work, that's why it's reliable. And now that you have designed a system where you are allowing systems to go down, nodes can go down, and you're okay with that. What this brings in, like, you do not really need these nodes to be very, very expensive servers. They can be very commodity hardware at a cheap price. Maybe not so much cheap, but I think it's much, much cheaper compared to a very high-end server. It is okay because we are fine. It goes down, I have something else which can take care of it. Because of that cost of these several nodes, each of node can be half the price. Maybe let's say we have saved half the price of the whole instance of the cluster. That's why it becomes economical. And this example cites out how effectively Hadoop is able to address scalability, being economical, and still reliable. So I love this example. It's a real day-to-day life example. People have seen this example in some point there in life. They can relate to it. There are a lot of good examples similar which can be cited out. I came up with this, and I think this really brings the point home. It sticks to the point, and people can correlate. So I would suggest, like, anybody next time thinking of Hadoop or fundamental core principles of Hadoop, think about a classroom, think about these scenarios, and these 3-4 words will really bring in together what the whole promise of Hadoop is, to which we are having.